right, so now we're going to be solving some quadratic equations. And as long as you follow these 4 steps, all of this should be okay. So, number 1, if necessary, arrange the terms so that one radical is isolated to one side of the equation. Remember, isolated means it's all by its lonesome. So you should rearrange it to where you have a radical equals stuff. Then what you want to do is raise both sides to the nth power to eliminate the nth root. So if you have a square root, you want to square both sides, right? Because that would cancel. If you have a cube root, you want to cube both sides because then that would cancel, right? Next, you solve the resulting equation. If the equation still contains radicals, then repeat steps 1 and 2. Isolate the radical again, do it to the nth power, so on and so forth. And then lastly, you have to check all of your solutions. Now, this is super important. You actually do have to check your equations. Because, so we have 2 times so far that you have to check your solutions, right? We already talked about when you have rational equations, right? Basically, when you have a fraction, if it's 1 over x, you have to check because x in this case can't be 0. And now the second one is even radicals, right? Because if you remember, a negative can't be inside a radical. So we have to always check ourselves. So this part, this checking, is part of the process. So sometimes it's not, a lot of times it's not, but in this case, you do have to check yourself. That is part of finding all the solutions. Because some solutions aren't going to be solutions at all. They're going to be what we call extraneous solutions, which means they look like solutions, but they actually aren't. All right, so let's go through this. Example number 1. So step 1, isolate the radical. Good, radical is already by itself. So then we're going to raise everything. Since it's a square root, we're going to square everything. So square one side, square the other side. The square and the square root cancel, so we get 2x plus 3 on one side, and 5 squared is 25. We subtract 3 to get 22, divide by 2, so we get 11. But we do have to check ourselves, right? We have to make sure that underneath this radical is not a negative number, right? Well, actually, we just need to check the whole thing. Excuse me. So 2 times 11 plus 3. So 2 times 11 is 22. 22 plus 3 is 25. The square root of 25 is 5. All right. So our solution set is going to be 11. Example number 2. All right, first step, isolate the variable. So you see the variable has a plus 6, or sorry, the radical has a plus 6 next to it. So we need to move that plus 6 over to the other side. So we subtract 6 to both sides, and we get the square root of x minus 3 is negative 1. Then we square both sides. Remember, you're squaring the entire thing, so that's including the negative. So you get x minus 3 equals positive 1. You add 3 to both sides, so you get x equals 4. But remember, you have to check. So we get the square root of 4 minus 3 plus 6. So 4 minus 3 is the square root of 1. Square root of 1 is 1. 1 plus 6 is 7. Does 7 equal 5? No. So that means that this is not a solution. So then what's the answer? So our solution set is just the empty set, right? We can either write it like this, or we can write it with a 0 with a line through it. Either way. And that's our answer. So here's actually a hint about it. You could see that from here, you don't need to know this, so If this doesn't make any sense, don't worry about it. You can just go through the steps that we did. Totally fine. But if you want maybe an explanation as to why this doesn't work, when does a square root, a positive square root, equal a negative number? Never, right? Positive square roots are always either 0 or positive. So this never happens, so that's why there's no solution. But again, if that doesn't make sense, or if you can't see that immediately, that's fine. Just go through the process, check yourself, you'll see there's no answer. All right, example number 3. So we want to isolate the radical, so we get the square root of 26 minus 11x equals 4 minus x. And then we square both sides. Now, when you square, you have to square the entire thing, since there is a minus sign here, right? We're not just doing 4 squared minus 8x squared. You actually have to distribute that. 4 minus x times 4 minus x. So we do 4 times 4 minus x, so 4 times 4 is 16. 4 times negative x is negative 4x. And you do negative x times 4 minus x. So negative 4x plus x squared. Then we need to solve. So we have a quadratic, so the way to solve is getting everything to one side. So we can combine these two first. So 26 minus 11x is 16 minus 8x plus x squared. So we're going to subtract 26 to both sides. And we see on this side, we're going to get negative 10. Then we're going to add 11x to both sides. And we see on the right side, we're going to get 3x. So if we want to write it to where it makes a little more sense, we can see that x squared, right? Positive x squared, positive 3x, negative 10. Make sure you keep those signs the same if you rearrange some things. All right, so if we factor, what two numbers multiply gets you negative 10, adds gets you 3. So that's positive 5 and negative 2. So x plus 5 is 0, which means x is negative 5. X minus 2 is 0, so x is 2. So now we have to check ourselves. So let's do negative 5 first. So negative 5, right, plus the square root of 26 minus 11 times negative 5. So negative 11 times negative 5 is positive 55. (26 plus 55), it's going to be 11, carry the 1, so 81. Square root of 81 is 9, which ends up being 4, which is exactly what we wanted. Good, so we definitely know that negative 5 is part of the solution set. Now let's check 2. So 2 plus the square root of 26 minus 11 times 2. So negative 11 times 2 is negative 22. 26 minus 22 is 4. Square root of 4 is 2. 2 plus 2 is 4. All right. So in both scenarios, we ended up with a solution, which means that the solution set is both negative 5 and 2. Two more examples, and then we'll be done with this lesson. All right, so now we got something a little harder. So we have two radicals, right? So notice step 1 just said let one of them be isolated. So let's just isolate the square root of 3x plus 1. So we can add that to one side. So we have the square root of 3x plus 1 equals 1 plus the square root of x plus 4. Now let's square both sides. Now again, remember, you have a plus sign. So you're going to have to distribute. the left side. It's not just 1 squared plus this squared, right? It's harder than that. So the left side, you get 3x plus 1. The right side, you get 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. So distributing, we get 1 times everything, which is 1 plus the square root of x plus 4. Then we get the square root of x plus 4 times everything. So that's plus the square root of x plus 4 plus, now if you're multiplying the square root of x plus 4 by itself, that's being squared, right? So that's the square root of x plus 4 squared, which means those are just going to cancel. So if we simplify things, we see it's 1 plus, we have 2 radicals, so 2 square root of x plus 4 plus, and since these two cancel, we just get x plus 4. So we still have a radical, right? So we have to go back to step 1 and isolate this variable again. So we subtract 1 to both sides, we see both of those disappear. Subtract the x, we get 2x minus 4 is 2 times the square root of x plus 4. We can divide everything by 2. So we get x minus 2 is the square root of x plus 4. And now we've isolated the radical, so now we can square both sides. And again, you have a subtraction, so the left side is going to have to be distributed. And the right side, of course, is just x plus 4. So, left side, you get x squared minus 2x minus 2x plus 4. So that combines to x squared minus 4x plus 4 equals x plus 4. You can subtract 4 to both sides, so that disappears. Subtract the x, so you get x squared minus 5x equals 0. Notice that both things have an x in common. So you have x times x minus 5 is 0, which means that x equals 0, and x minus 5 equals 0, which would mean x equals 5. So now we got to check ourselves. So let's check 0 first. So the square root of 3 times 0 plus 1 minus the square root of 0 plus 4. So we're just plugging in 0 for x in our beginning. So 3 times 0, which is 0, so we get the square root of 1 minus the square root of 4. Square root of 1 is 1, square root of 4 is 2, so 1 minus 2 is negative 1. Is that what we wanted? No. We wanted positive 1, which means that 0 is an extraneous solution, so that's not a solution at all. Now let's check positive 5. So the square root of 3 times 5 plus 1 minus the square root of 5 plus 4. So 3 times 5 is 15. 15 plus 1 is 16. So we get the square root of 16 minus 3 times 5 is the square root of 9. Square root of 16 is 4. Square root of 9 is 3. So 4 minus 3 is 1. And that's exactly what we wanted. So we see that the solution set is 5. And again, if you didn't check, right, you would have had 0 and 5, and that would have been incorrect. All right, let's do one more like that, and hopefully we'll feel okay with this section. All right, so again, we have 2 radicals. So let's just isolate one of them. So let's move this to one side. So we get the square root of x plus 5 equals 2 plus the square root of x minus 3. So we square both sides, which means that we actually have to distribute the second one because there's a plus sign. So we get x plus 5 is 2 times 2, which is 4, plus 2 square root of x minus 3, plus 2 square root of x plus 3, plus, and again, we're going to have two radicals. It's the exact same multiplied by itself, so that's just squared it. So that's going to disappear, so it's x minus 3. We can combine these two, and we can, which will be 4 square root of x plus 3. And then we can combine the positive 4 and negative 3 to get x plus 1. So moving everything, now we need to isolate this radical, right? So move everything to the left. So x's cancel. So we subtract the 1, and we get 4 equals 4 square root of x plus 3. And then divide by 4. So we just get 1 equals square root of x plus 3. Square both sides. So we get 1 is x plus 3, which means that x is negative 2. And we're done. Hopefully you thought no, because we also have to check it, right? That's part of the process. So we get, oh, sorry, hold on. Oh, it's supposed to be x minus 3. Yeah, sorry. I'm sure y'all saw that. Yeah, this doesn't just go from x minus 3 to x plus 3 magically. So this should be x minus 3. Excuse me. So then you add 3 to both sides. So then x is 4. Okay. There we go. I apologize. Hopefully y'all all caught that. All right. So when we check ourselves, let's plug 4 in for x. So we get the square root of 4 plus 5 minus the square root of 4 minus 3. 4 plus 5 is 9. 4 minus 3 is 1. Square root of 9 is 3. Square root of 1 is 1. So 3 minus 1 is 2, which is exactly what we wanted. So we see that the solution set is just 4. All right. Like always, let me know if you have any questions. Other than that, have a great day.